Okay, today we are going to be solving our equations, and we are going to use different techniques to do this. Sometimes there's more than one technique that will work for a particular problem, and sometimes there's only one way to solve a problem. So one of the techniques that we're going to learn, we've already talked about this earlier, was to change the bases so that they were equal. We did this on the very first day that we had when we did the M&M problems. Remember when we were trying to get the bases to be the same? We did this one already. So that's what we're going to do with this first technique. So we're going to go ahead and rewrite 8 as base 2. So 8's the same thing as 2 to the third. And we already had an x there, so we'll just have to multiply that together. So, and then 2 is raised to the 1 power, right? We don't write it, but it's raised to the 1 power. So now that my bases are the same, all I have to do is look at the exponent spot. So 3x equals 1, so x equals 1/3. And that makes sense because a power of 1/3 is taking the cubed root. And if you took the cubed root of 8, you would get 2. So I know that works. Over here, I've got 20 times 1/2 raised to the x divided by 3 power. So first thing I want to do, if I want these bases to be the same, I just need to have them as two bases. So this 20 times a base isn't going to work. So I'm going to divide the 20 to the other side, and you're going to have 1/2 x divided by 3 equals 5 divided by 20, and 5 divided by 20 is 1/4. So now I've got like that. Okay, so now we've got to rewrite that. So 1/4 is the same thing as 1/2 times 1/2, right? So I'm going to write that because my base on the other side is 1/2. So I'm going to say 1/2 equals 1/2 raised to the second power. And then now my bases are the same, so I can say x over 3 equals 2, multiply both sides by 3, so the answer is 6. If you put a 6 in there, you'll get the same answer as what we would equal 5. So 6 divided by 3 is 2. 1/2 raised to the second power is 1/4. 20 times 1/4 is 5. It's true. Everything works. Okay, now same problems, but we're going to do this different technique, and we're going to rewrite it as a logarithm. So right now I've got 8 to the x power equals 2. So if I rewrite that as a logarithm, it would go log base 8 of 2 equals x. And so now I'd have to evaluate this on my calculator. So if I had a change of base button, I would just type in log base 8 of 2. If not, I'm going to do change of base formula. So I'm going to do log of 2 divided by log of 8. I know base 10 is on all of our calculators. So we're going to go ahead and figure out what that number is. So when I do that, I get 0.3333, which is a third. I know it's a third. We've already done that on the other problem. So x equals a third. So over here, same thing. Before I do the rewrite, though, same thing as on the other slide. I really just want it to be a base raised to a power. So I'm going to have to manipulate this 20. So I'm going to say 1/2 x divided by 3 equals 5 divided by 20, which is our 1/4. So before I rewrite it into a logarithm form, I'm going to want it to look like this. So now I'm going to rewrite that, and I'm going to say log base 1/2 of 1/4 equals x divided by 3. So once again, I could do change of base. So log of a fourth, I'll write that as a decimal, 0.25, divided by log of a half, so I'll write that as a decimal. And so now let's go ahead and, if you have a change of base button, you could do that on your calculator. Otherwise, we're just using the formula. So log 0.25 divided by log of 0.5 equals 2. And so you have x over 3 multiplied by 3, and we get x equals 6. So same problem. So on the other side, we did change them to the same base. This side, we rewrote them in logarithm form. Here's another technique. This one, I would, now you could do rewrite on this one also, or you could do what's called taking the log of both sides. So I'll do both so you can see. This one, taking the log of both sides, is a new technique. I wouldn't do change of base on this one because I can't change a 1.06 to a 4.1 or vice versa. So that one definitely is out. I could rewrite that as a logarithm, which probably is the easier technique. But I'm just going to show you this new technique just so you'll have it. And I'll show you both ways. So taking the log of both sides means that you're just going to write the log of something on both sides. Now, you got to pick a base. So basically, you could pick log base 10 because that's on your calculator. Log base E, which is natural log, because that one's on your calculator. Or you can pick the two numbers that are over here, the 1.06. So basically, we could do 1.06 or 4.1. So 10 or E. Those are what we would want to choose. I'm just going to do 1.06 just because that's the base raising to the variable. You could do 4.1 and it would still work. But since we only have one variable and it's attached with 1.06, that's what I'm going to do. So if I take the log of both sides, I'm going to say log of base 1.06, okay, of, and then I write 1.06x equals, and then I do the log of 1.06 of 4.1. So see how what I did when I say I take the log of both sides, I added this log base out in front to each of these argument pieces right here. Okay, so now I actually have to go and figure out what this is. Well, the nice thing about picking the same base right here as this base right here is that I know when those two bases are the same, the answer is whatever this power is, so it's x. So x equals log base 1.06 of 4.1. And then we could go to our change of base formula and do log of 4.1 divided by the log of 1.06. And x is going to turn out to be, so let's go ahead and figure that out. Log of 4.1 divided by log 1.06. That's about 24.22. Okay, let's do the same problem, but we'll just do it as a rewrite. And you can see that it just kind of skips the middle step here, the putting the log on both sides. So it's a little quicker, a little easier to remember. Taking the log of both sides has its place, but like I said, it's probably easier just to do the rewrite on this one. So here's our original problem. Let's get some more room. 1.06 raised to the x power equals 4.1. So if I were going to rewrite that as a logarithm, I would say log base 1.06 of 4.1 equals x. So see how we just got to skip that whole middle, take the log of both sides. But knowing what base to choose on taking the log of both sides is kind of an important property, so that's why I show it. And now we're back to change of base, so log of 4.1 over log of 1.06 equals x. Go to our calculator, and x is approximately 24.22. Okay, so we'll do the same one. We'll do it two ways just so you can see. So if I were going to pick a log, so I'm going to do the log of both sides. So basically my choices would be 7 because that's the base, 3 because it's a number on the other side, 10 because that's on my calculator, and E because that's on my calculator. I'm going to choose 7 because it's 7 raised to that power. So I'm going to write this as log base 7 of 7 to the x equals log base 7 to the third. All right, well, 7, log base 7 of 7, that's just going to be our power. So x equals log base 7 of 3. So this would be kind of a good technique if you forgot how to do the rewrite and you're like, oh, I can't remember which number goes where. You could just take the log of both sides and you'd end up with the right answer. So x equals log base 3 divided by log base 7. So let's go ahead and figure out what that decimal is. Log base 3 or not log base 3, sorry, log 10 of 3. So the base is 10. So 3 divided by log 7. And we end up with about 0.56. Okay, so once again, same thing. If you were going to do a rewrite on this one, um, you could skip this step right here is basically all you do is skip this step right here. So if you forgot how to do the rewrite, taking the log of both sides will get you to that step. So rewriting it would mean I would say log, and this is my base right here, so base 7 of 3 equals x. And then we know that change of base, that turns out to be the 0.56. So we've got taking the logarithm of both sides. So we've got rewriting in logarithm form, changing our bases, taking the log of both sides. Okay, we can do expanding or condensing. So if you have multiple logarithms, the goal would be to get them to a single logarithm if you could, or to the same logarithm on both sides. So on this one, I have 3 logarithms, so I think I'll condense the 2 on the left, and so since they're being added together, that's going to go the log of x minus 2 times x plus 5 equals, and then on the right, I've got 2 log of 3. I'm going to take that 2 and put it back as a power, so I'm going to have log of 3 squared, like that. Now, because I have these two the same logarithms, these are both 10 right here, all I have to do is compare the argument spots. Those two have to be the same, so I'm going to kind of ignore the logarithms for a minute, and I'm just going to figure out what we have here. X minus 2 times x plus 5 equals 3 squared. I'm going to multiply this out. X squared plus 5x minus 2x, so that's plus 3x, minus 10 equals 9. Well, since this is a higher degree, we're going to want to put it equal to 0. So x squared plus 3x minus 19 equals 0. So we're going to want to factor that if we can, and if we can't, we're going to put that in the quadratic formula. So I'm going to go ahead and put that in the quadratic formula. So x equals opposite of b plus or minus b squared minus 4 times a times c divided by 2 times a. So negative 3 plus or minus the square root of, let's see what's under our radical. So 9 minus 4 times 1 times negative 19 is going to be 85 over 2. All right, so let's just go ahead and figure out what the decimals are. So we're going to say, I'm just going to figure that out, negative 3 plus the square root of 85. And then we're going to take that, you're going to probably want to make sure you have that in parentheses in the numerator so that it'll divide everything by 2. So square root of 85, and then divide by, whoops, sorry, let me, divide by 2. So that as a decimal is about 3.11. Okay, and now I'm going to do the subtract. So I'm going to go negative 3 minus the square root of 85 divided by 2. And that as a decimal is about negative 6.11. Okay, now we're going to have to throw out this second answer because if you put that up in the original problem, a negative 6.11 plus 5 is going to give you a negative number, and we can't take the logarithm of a negative number because it's of our domain restrictions. So our answer is 3.11. And you could check that. You could put the 3.11 in there and see if you got the same answer on both sides. But we did have to throw out the negative 6.11. Okay, so here we go. This one, once again, remember my statement. We either want to condense this down to 1 logarithm if we can, or 1 logarithm on either side. Since there's 2 logarithms here and they're both on the same side, we could go ahead and condense them down into 1 logarithm. So let's do that. The 1/2 is going to be the power, so this is going to be natural log of x minus 3 raised to the 1/2 power, and then minus the natural log of x. So if we keep writing, that's going to be the natural log of, now 1/2 power is the square root, so that's going to be the square root of x minus 3 divided by x, and that's all going to be equal to 0. So now I'm going to go ahead and rewrite this so that I can, remember we're trying to figure out what x is, and that didn't give me x equals. So since my x is in the argument spot of a logarithm, you're going to want to take it out of a logarithm. If you can't figure it out written as a logarithm, you want to take it out of logarithm form. So to do that, I'm going to rewrite it into exponential form. You have to know what your base is, so that's a base e. So this is going to be e to the 0 power equals the argument. So the square root of x minus 3 over x. Okay, well, e to the 0 is 1. And now we're going to solve this for x. So I'm going to multiply both sides by x to get rid of that fraction. So I'm going to have x equals the square root of x minus 3. Now I want to get rid of the square root symbol. So to do that, I'm going to square both sides. I'm going to have x squared equals x minus 3. Remember, we squared both sides right here so that we could get rid of the square root symbol. And now because I have a higher power, I want that to be equal to 0 and see if it'll factor. So x squared minus x plus 3 equals 0. So once again, not going to factor, so we're going to go to the quadratic formula. So x equals opposite of b plus or minus b squared minus 4 times a times c divided by 2 times a. So x equals 1 plus or minus the square root of, that looks like negative 11 over 2. So 1 plus or minus I root 11 over 2. So since we're in the imaginary plane here, and we normally graph on the real plane, this is going to be a no solution. Okay, here we go. We've got log base 6 x plus 16 plus log base 6x equals 2. Okay, first of all, you need to understand that this 16 right here is not grouped with that x. That is not grouped with that x. It's not in parentheses. If it was grouped, it would have parentheses around it, okay? So 16 is just some number. I'm going to move it to the other side. I'm going to get it out of the way with the 2. It's like terms with the 2. So basically what I'm going to have right now is log base 6 of x plus log base 6 of x equals negative 14. Well, log base 6 of x plus log base 6 of x, those are like terms. There's 2 of them. So we'll go ahead and write that as 2 log base 6 of x equals negative 14. And then I'm going to go ahead and raise that to the second power. So log base 6 of x squared equals negative 14. And then we'll just go ahead and do a rewrite. So 6 raised to the negative 14 power equals x squared. That's a really small number. So x is going to turn out to be plus or minus the square root of 6 raised to the negative 14 power. So that's going to be, now remember, the 1/2 power, the square root symbol is the same as the 1/2 power. So if I write it like this, then at least that'll change our decimal to a little bit smaller. We're going to end up with plus or minus 6 raised to the negative 7 power. So that's going to be 7 decimal places to the left. So you're talking about x equals plus or minus 0.0000. Let's see, 1, 2, 3, 4, 5, 6, and then this is 6. So 1, 2, 3, 4, 5, 6, 7. Yep. So there we go. There's our two answers. We're going to throw out that negative 0.006 because if I put that up there in the top, the logarithm of base 6 of x, that's going to give me a negative number. So we're just going to say, oh, wait a minute. Sorry. That's not 0.00. I was thinking scientific notation. I don't know why I was thinking that. Backtrack. That is not the right number. Don't know why I was thinking that. I had scientific notation on the brain. 6 raised to the negative 7 power is not, it'd be 6 times 10 to the negative 7 power. Sorry, that was my mistake. So 6 raised to the negative 7 power, I don't know why I was thinking scientific notation, is, so back again here, it's 0.12345 3572. But once again, we can still eliminate the negative answer, and so now we'll write this in scientific notation. 3.572 times 10 to the negative, what is that? 1, 2, 3, 4, 5, 6. Like that. And we won't use the negative value, just the positive. Okay, so if you noticed on this slide over here, when I was solving, right here in this step, this power, you could divide it over here if you wanted. And in this particular problem, it would have been okay to do, but not in this particular problem. You would get an answer because of the way the original problem is written. The original problem is written with the argument being squared right here. So it doesn't matter what you put in for x, since you're squaring it to begin with, it's always going to be positive. So in this format, you can have a negative answer. So you don't want to divide out even powers. I'll show you what I mean. I'll do it the right way, and then I'll divide out the power so you can see why I'm saying don't do that. So if we were going to do this one, to start it out, I would, I've got log base 10 of x squared. So I'm just going to go ahead and do a rewrite. So here's my base. And I would say 10 squared equals x squared. And then when you take the square root of both sides, 10 squared is 100, right? And when you take the square root of both sides, you get x equals plus or minus the square root of 100, which is 10. You get plus or minus 10. In this particular problem, negative 10 is okay. When you put negative, because the original problem was written with the x squared. On this slide over here, the original problem only had an x, and so when we divided it, it would have worked, but it won't work on this one because negative 10 squared will still give you a positive 100. So negative 10 is an answer. There are two answers here. X equals plus or minus 10. Both those answers are good. Now, watch what happens if I divide it out. So what I'm going to do is I'm going to bring the power out. Log base 2 log base 10 of x equals 2. Then I'm going to divide the 2 to the other side. And I'm going to get log x equals 1. And now I'm going to do my rewrite. Here's my base 10. So I'm going to say 10 to the 1 equals x. And then x equals 10. See how I only ended up with one answer? I missed an answer. I missed the negative 10. So you need to be careful when you have even exponents. If you're unsure, oh, can I divide it or not? Don't do it. If you don't know that it's going to work, then don't do it. You can, odd exponents are okay, but dividing out even exponents, so what am I talking about? I'm talking about when I brought this power out to the front, so it was right here, and then I divided it over here. If this number right here is an even number, that may or may not give you all the answers you need. If it's odd, it's okay to divide it out, but even, you got to be careful. So you got to be careful with those even exponents when you're solving, when you're dividing. Okay, and then these last two are ones where we're going to have to use our graphing calculator. We can't do the algebra on that. So on this first one, you're just going to want to type in into y1, we're going to type in e to the 2x minus 8x. And then in y2, we're going to type in -1, and then we're going to find out where they intersect. Okay, so just a minute, I'll get my calculator up and we will do that. Okay, so I'm going to type in e, and my e is right here. So e to the 2x minus 8x. And then I'm going to type in -1 on the graph. Okay, I'm going to do zoom 6, get a 10 by 10 window. Okay, so it looks like to me these are our two intersections right here. It looks like there's two answers. So I'm actually going to make my window go from, in the y, I'm going to go from -2 to +2, just so I can see that a little bit better. There we go. And now I'm going to do intersect button. So intersect. So yes, that's my first curve. Yes, that's my second curve. And now I'm going to make my guess is right there. So one of our answers is 0.41. I guess we'll go with 0.41. Okay, and then let's figure out what the other answer is. So we'll do intersect again. And yes, yes. And then over here, enter. And so that looks like that's like what, 0.93? So our other answer is about 0.93. Okay, now we'll do the other question here. So log base 2, or 2 log base 10 of x minus 4 log base 10 of 3 is greater than 0. So there's a couple of ways we could do this one on our calculator. Let's go ahead and slide this over so we can see this a little bit better. And I'm going to go ahead and, right, let's delete that. So here I'm going to clear that one out. I'm going to clear that one out. I'm going to put it back to a 10 by 10 window. Okay, so I'm going to go 2, and then I'm just going to hit log x, and then minus 4 log 3. Okay, now I can just type this one in and do zeros if I wanted, or you could type in, I think I'll just, since it's saying greater than 0, I think I'm just going to type this in and hit graph. So what we're looking for, I'm going to change my window now because I don't need all this stuff at -10. I'm going to go -1, and then I'm going to make my y max go to 20. Because what we're looking for over here, it says, where is the log of, so where is this logarithm stuff right here, all of this logarithm stuff, where is it greater than 0? Greater than 0 means above the x-axis. So if we look, looks like to me it's in this area here somewhere is where it starts to go above. So what we need to do is find that 0. So I'm going to go under calculate, find the 0. So left bound, I need to be on the left-hand side of that somewhere. So I make sure I'm on the left hand. It's hard to tell where it's at. So I'm going to go enter just because it kind of flattens on there on the x-axis. So I'm going to give myself a little bit of room here, buffer room, to where I know I'm on both sides of it. And then I'm going to put my guess in here somewhere. And 9. So the answer is 9. So x equals 9. So we want to know where it's greater than 9. So we're going to say 9 to infinity. We didn't put a bracket on that because it didn't say greater than or equal to. It just said greater than. So if you look on our graph one last time, from 9 to the right, everything is above 0. So it's above the x-axis. Okay, there you go. So we've got different techniques to solve problems, and this is kind of hard because you have to be able to figure out which technique to use when. That's what makes this homework kind of hard. I don't tell you which technique, it just says solve, and you have to figure out what would work best.